Hello my learners, welcome to my channel. If you have not subscribed to my channel, please subscribe for more videos. Today let's see on how to find the stationary points on the following curves and determine the nature of each point. So we have the first equation, that is Roman 1, y equals to 4x cubed plus 9x squared minus 3x plus 10. And then we have another equation, that is Roman 2, y equals to x to power 4 minus 8x cubed minus 3x squared plus 36. So let's see one by one. Let's begin by the first equation. So our first equation, that is Roman 1, y equals to 4x cubed plus 9x squared minus 30x plus 10. So we have two questions in one question. So we have to find the stationary points of these curves, and at the same time we have to determine the nature of each point. So let's begin by finding the stationary point of this curve. Now, the stationary point, for any stationary point, dy over dx equals to 0. For any stationary point, dy dx equals to 0. So we have our equation as y equals to 4x cubed plus 9x squared minus 30x plus 10. So let's find the derivative of this equation. So that is dy over dx of this equation with respect to x. So that is 4x cubed plus 9x squared minus 30x plus 10. So on this side we have dy over dx equals to the derivative of 4x cubed, that is 12x, and then you less the power by 1, that it will be x squared, plus you take these two multiply by this, that is 18, and then you less the power by 1, that it will be 18x, minus 1 times 30, that is 30, you less the power by 1, it will be 0. X raised to 0 is just 1. So 1 times 30, it is 30. And then we have this constant 10. So the derivative of any constant equals to 0. So no need to work out this one, because if you find the derivative of any constant, the answer equals to 0. So we have our first derivative as 12x squared plus 18x minus 30. And I've said that for any stationary point, dy dx equals to 0. So that means we have to equate this equation to 0. So we have 12x squared plus 18x minus 30 equals to 0. So you can simplify this further, because this is 12, 18, and we have 30. So we can simplify by dividing by 6 because 6 is divisible to 12, 18, and 30. If we simplify, that is 6 into 12, that is 2, 6 into 18, that is 3, and 6 into 30, that is 5. So that gives us an equation as 2x squared plus 3x minus 5 equals to 0. So this is a quadratic equation. We can simplify any quadratic equation using the three method, that is a quadratic formula method, complete square method, and factorization. For me, let me use factorization method. So in factorization method, first we need to find the product, and the product is just the multiplication of A times C. So A times C, that is a negative 10, and then we need to find sum. So sum, we just take the value of B in that quadratic equation, of which is 3. So after that, you need to find the two number. When you multiply, you get negative 10, and when you add those two number, you get positive 3. So that numbers are 5 and negative 2. After that, you have to substitute here with these two number. So we have 2x squared. Let me substitute with a negative 2x and then positive 5x and then minus 5 equals to 0. So after that, you group these into 2, and then you factor out the common factor. So in first group, the common factor is 2x. It is 2x. When I factor out these 2x, I will remain with x minus 1 plus the second group. The common factor here is 5, so I have to factor out 5 such that I remain with x minus 1 equals to 0. After that, I pick these 2x plus 5, and then x minus 1 equals to 0. Goes to 0. So you have to equate each group to 0. So we have these 2x plus 5. Let me equate to 0. So I bring this positive 5 on the other side, such that I have 2x equals to negative 5. So to find the value of x, I have to divide by 2 by 2, so that x, the value of x equals to negative 2.5. Negative 2.5. And then you come on this other group, that is x minus 1, you equate it to 0. And then you bring this negative 1 on the other side of the equal sign, such that you have your x as 1. So we have got the x coordinates of the stationary points which we are looking for. So let's now find the values of y. So the value of y when x equals to 1. So we have our y as y equals to 4x cubed plus 9x squared minus 30x plus 10. So to find the value of y, you have to substitute x with 1. So we have y equals to 4 into 1 cubed plus 9 into 1 square minus 30 into 1 plus 10. So if let's see what we will get. So we have 4 into 1 cubed plus 9 into 1 square minus 30 into 1 plus 10. That gives us negative 7. So that is negative 7. And this now gives us the first stationary point. First stationary point as 1, negative 7. That is our first stationary point. Let's now find the value of y when x equals to negative 2.5. So we have y equals to 4 into negative 2.5 cubed plus 9 into negative 2.5 square minus 30 into negative 2.5 plus 10. If you work out in your calculator, you will get 78.75 as the value of y. So now this now gives us the second stationary point, gives us the second stationary point as negative 2.5, 78.75. So far we have found the stationary points, that is negative 2.5, 78.75 and 1, negative 7 as our stationary points. So we have again to determine the nature of each and every stationary points. Let's begin by point 1, negative 7. So to find the nature of this stationary point or any stationary point, you have to find the second derivative of your equation. So let's find the second derivative of our equation, of which is after first derivative we got 12x square plus 10x minus 30. So let's find second derivative and see. So we have 12x square. So derivative of 12x square is 24x. This is not 10, but it is 18. And then plus derivative of 18x, that is 18. So this is now our second derivative. Now to determine the nature, you have to substitute x coordinate of your stationary point to this second derivative. So let's substitute and see the result. So we have 24 into 1 plus 18. So if you work out, you will get positive 42. So because the answer is a positive value, because it is a positive value, this point, so stationary point, point 1, negative 7 is is a local minimum. That is the nature of these stationary points. So we have another point as negative 2.5, 78.75. So to determine the nature, you have to know the second derivative of that of your first equation. So the second derivative, you have got 24x plus 18. So, and then you substitute the x coordinate of your stationary point to this second derivative. So let's substitute. So we have 24 into negative 2.5 plus 18. So that gives us negative 42 as our answer. So because the final answer gives us a negative value, so this point negative 2.5, 78.75 is a local maximum. Up to that point, we have handled both stationary point and the nature of this curve. So let's see the other equation. So the other equation was y. It was y equals to x into 4 raised to 4 minus 8x cubed minus 3x square plus 36. So we have to find the stationary point of this equation, of this curve, and also the nature of this curve. So let's begin by finding the stationary point, and remember to find any stationary point, dy over dx equals to 0. So that means first step you have to find the first derivative of that equation. So we have dy over dx. Let's find first derivative with respect to x of x raised to 4 minus 8x cubed minus 3x square plus 36. So that is dy dx. So dy dx of the derivative of x raised to 4, that is 4x cubed minus 8. Derivative of 8x cubed, you take 3 multiplied by 8, that gives us 24, and then you raise the power by 1, that is x square, minus, you take the power multiplied by this, that gives us not 9 but 6, that gives us 6x, you raise the power by 1, you get x. So the derivative of a constant always equals to 0, no need to work out that. So after that, we have to equate this 4x cubed minus 24x square minus 6x equals to 0. We have to equate to 0. Now, before that, I can see the common factor in here. So the common factor in between 4x cubed, 24x square, and 6x, it is 2x. So you factor out that common factor. When I factor out 2x here, I will remain with 2 x square minus 12x minus 3 equals to 0. So from here we can obtain the first value of x by taking 2x and then you equate to 0. So divide by 2 by 2. So that means the first value of x is 0. The first value of x is 0. So, and then we have these 2x square minus 12x minus 3. We have to equate it to 0. So this is a quadratic equation. We can use those three methods. So let me use quadratic formula, which says when you want to find the value of x, you pick negative b plus or minus the square root of b square minus 4ac divided by 2a. So our x equals to, so the value of b is negative 12, so negative times negative gives us positive, so that means we have here positive 12 plus or minus, so b square that is 12 square, and it gives us 144 minus 4 times a, that is 2. So 4 times 2 times c, that is 3, times negative 3, it gives us negative 24 over 2 times a is 2, so 2 times 2 gives us 4. So we have x equals to 12 plus or minus the square root of 144. Negative times negative gives us positive, so positive 24 over 4. So we have x equals to 12 plus or minus, so 144 plus 24, it is 168. So the square root of 168, it is 12.96 divided by 4. So the first value of x you take with a positive sign, that is 12 plus 12.96 divided by 4. It gives us 6.24. 6.24. The second value of x you take with a negative sign, so we have 12 minus 12.96 divided by 4, so we have negative 0.24. So far we have three values of x. So the first value of x we have 0, the second value we have 6.24, and the third value of x is negative 0.24. So let's now find the y coordinate of stationary points. So let's begin by finding the value of y when x equals to 0. So we have our y as x raised to 4 minus 8x cubed minus 3x squared plus 36. So let's substitute where x is with 0. So we have 0 raised to 4, 8 into 0 cubed minus 3 into 0 square plus 36. So the value of y here is 36, and now this gives us the first stationary point. First stationary point as 0, 36. That is our first stationary point. So let's find the value of y when x equals to negative 0.24. So we have y, we substitute where x is with negative 0.24. So we have negative 0.24 raised to 4 minus 8 into negative 0.24 cubed minus 3 into negative 0.24 square plus 36. So let's see what we shall get. So we have negative 0.24 raised to 4 minus 8 into negative 0.24 cubed minus 3 into negative 0.24 square plus 36. So we have our value of y as 35.94. So we have 35.94, and this gives us the second stationary point. Second stationary point. The second stationary point as negative 0.24, 35.94. Let's find the value of y when x equals to 6.24. So you substitute where x is with 6.24. So we have y equals to 6.24 raised to 4 minus 8 into 6.24 cubed minus 3 into 6.24 square plus 6 plus 36. So let's work out. So we have 6.24 raised to 4 minus 8 into 6.24 square, not square, cubed, minus 3 into 6.24 square plus 36. So we have our value of y as negative 508.44. And now this gives us our third stationary point. Our third stationary point as 6.24 negative 508.44. So let's now find the nature. of these stationary points. So before we find the nature of a stationary point, so we have to know the second derivative. The second derivative of our equation. The second derivative of our equation, we have 4x cubed as our first derivative minus 24 x squared minus 6x. So let's find the second derivative. So the derivative of 4x cubed, that is 12x squared minus derivative of 24x squared, that is 48x, and the derivative of 6x, that is 6. So let's find the nature of our first point. So for point 1, negative 7, not 1, but for 0, 36. So we have to substitute our x coordinate to our second derivative equation with 0. So x with 0. So we have 12, we substitute with 0, square minus 48 into 0 minus 6. So if you work out, you will get negative 6. So because we have got a negative value, because we have got a negative value, so that means point 036 is a local maximum. That is the nature of point 036. So for point negative 0.24, 35.94. So we're going to take 12 and then we substitute x coordinates. So we have negative 0.24 square minus 48 negative 0.24 minus 6. So let's work out and see. So we have 12 into negative 0.24 square minus 48 into negative 0.24 minus 6. That is 6.21. That is 6.21. So because we have got a positive value, so that means point negative 0.2435.94 is a local minimum. That is the nature of this point. Point negative 0.24 35.94 is a maximum point. So let's see the last point, that is for point 6.24 negative 508.44. So we have to substitute to our second derivative with this x coordinate, that is 6.24. So we have 12 into 6.24 square minus 48 into 6.24 minus 6. So let's work out. So we have 12 into 6.24 square minus 48 into 6.24 minus 6. So that is 161.73. 161.73. Still, this is a positive value. This is a positive value, and that means 0.624 negative 508.44 is a local minimum point. So 0.6.24 negative 548.44 is a minimum point, and that is how to work out the stationary point and to determine the nature of any curve. So thank you.